In this class here, we're going to stick to one kind of work, which is expansion work. Okay, so expansion work, for instance, or compression work, is if you have a piston with a gas in it. All right, you put a pressure on this piston here, and you compress the gas down. This is compression work. Now the volume gets smaller. P external here. Pressure, the piston goes down by some volume L. The piston has a cross-sectional area A. And the force, pressure is force per volume area, right? So the force that you're pushing down on here is the external pressure times the area. Pressure is force per volume area. That's the force you're using to push down. Now the work that is calculated when you push down with the pressure on this piston here, that work is force times distance, right? F times L. F is P external times A times the distance L. So that's P external times the change in the volume. The area times this distance is a volume, and that is the change in volume from going to the initial state to the final state. Okay. Now we need to have a convention. Okay, we've got force, work is force times distance, is P external times delta V, and I'm going to be stressing a lot that this is the external pressure. This is the pressure that you're applying against the piston, not the pressure of the gas. It's the pressure that the external world is applying on this poor system here. Okay, but we need a convention here. The convention, and then we need to stick to it. And this convention, unfortunately, has changed over the ages. But we're going to pick one, and we're going to stick to it, which is that if the environment does work on a system, if we push down on this thing and do work on it to compress it, then we call that work negative work. Right? Now, we call that work positive work. All right. So that means we need to put a negative sign right here by convention. So if delta V is negative, in this case, delta V is negative, okay, delta V is negative, pressure is a positive number, negative times negative is positive, work is greater than 0. We're doing work on the system, to the system. In this case here, work is positive. If you have expansion on the other side, if the system is expanding in the other direction, if you're going this way, right, you're going to do work to the environment. There might be a mass here. This could be a car. A piston's in a car, right? So the piston goes up. That's going to drive the wheels. The car is going to go forward. You're doing work on the environment. Delta V is going to be negative. W is going to be negative. Sorry, got it backwards again. Delta V is positive in this direction here. The work is negative. Okay. So work on the system is positive. Work done by the system is negative. Convention. Okay. This negative sign is just a pure convention. Just got to use it all the time. If you use an old textbook written when I was taking thermodynamics, they have the opposite convention, and it's very confusing. But now we've all agreed on this convention, and work is going to be with a negative sign here.